Now let's look at variable length records. These are records that have a column type that is a variable length, like a string type, for example. And the length of the records may differ from row to row of the table because different strings will have different lengths. So when we pack these things into a page, it's hard to know where each record begins on the page and where each record ends. Page 2, record 4, for example, in this picture, what is the offset that record 4 is at? Another question is what happens when we add and delete records. So suppose we delete a record that's small and we want to insert a record that's big. It won't fit in the hole left from the record we deleted. So we're going to need to think about how to manage empty space on the page. So as a starting point, we're going to redesign our scheme for fixed length records in a few ways. First, we're going to put our metadata in the end of the page, the footer, rather than the beginning of the page, the header. And we'll see why this is handy in just a minute. Next, we're going to fill up that footer with a somewhat different kind of metadata. We're going to have what's called a slot directory. So the very first entry in the slot directory, all the way at the end of the page to the right, so this is the first entry from the end inwards, is a pointer to free space. And this is the place where new records are going to get inserted. And then for each other entry in the slot directory, we're going to have a pair, which is a length of a record, and a pointer, or if you like an offset, on the page to the beginning of the record. So for example, the first slot on this page is populated with a record that's length 16, and it's at offset 0 of the page. So that green arrow pointing to the beginning of the page is actually stored as the number 0. That's the offset on the page where that record begins. The second record is of length 24, and it's at some other offset of the page, which again is an integer representing the number of bytes from the beginning of the page to where the record starts. So that green arrow is essentially an integer offset on the page. That pair of a length and a pointer determines the beginning, the pointer, and the end, pointer plus length, of the record. Right? Recall that the slots are stored in reverse order, right to left, so to speak, in the slot directory. Okay? So record ID 4 is this thing that's pointed to at the bottom. It's the fourth slot from the right. It's the one with length 12. Now suppose we wanted to delete that record. How would we do that? Well, deleting it's actually quite simple. We're just going to set that slot directory pointer, that entry there, to null. It's going to have a null length and a null pointer. Now this isn't going to affect the pointers to any of the other records. It's simply an entry change in the slot directory. Effectively, however, the storage that used to be occupied by that record is now unused, right? It's unaddressable even. If we wanted to insert a new record now, how would we do it? Well, we begin by looking where the free space pointer points. So we would put it at the end of the page here where the free space pointer points. We'd create a new entry for it in the slot table. Here we'll reuse slot number 4. So this is going to be the new record 4 on this page, and it's got a different length. Let's say it's 42. Okay, and a pointer to what is currently the beginning of free space. So we copy the free space pointer in there. And then we change the free space pointer to be 42 bigger than it was before to account for the space we just used up. So that's how an insert would work. It's really very simple. It just goes at the end of the page and we update the free space pointer. Now inserts can go into any empty slot we like. One of the problems that arises here is we've got free space fragmentation on this page. There's some free space up at the top from where we deleted something before, and of course there's some free space still left at the end. We might want to consolidate that free space to make room for a big record that gets inserted later. So how are we going to do that? Well, we're going to reorganize the data on the page. We're basically going to pack all the records back together and then change the pointers to reflect the new locations of the records after we repack them. Okay, so let's talk a bit about this reorganization. Let's ask some leading questions. First of all, is it safe to reorganize these records whenever we want? And the answer is yes. It is safe because people who are using the API pointing to these records are referring to them in terms of page ID, slot ID. So page 2, record 4 is looked up on this page by looking in slot directory number 4, which in turn has a pointer. But everybody outside, all the APIs into this data structure, into this page, remain the same. It's a page ID, slot ID. So that's great. So then the only remaining question we have to answer is when should we bother reorganizing the page? Should we do it sort of eagerly or can we be lazy about it? So the eager scheme would be to reorganize right when we delete a record. All right. The alternative would be the lazy scheme, which is we don't need to reorganize until we run out of free space at the end of the page. And at that point, we could take the time to reorganize. It's not a big trade-off, but it often pays to be a little bit lazy in this case. Maybe the page won't get more records inserted and the time for reorganization isn't necessary. A more interesting question, perhaps, is what if we run out of slots in the footer, but there's plenty of space for new tuples? Well, here's where having the footer at the end is a good thing. So we'll track the number of slots in the slot directory. We actually didn't record this before. We'll need to track that. So at the far right, you can see we've modified our design now to have a number of slots as the first entry on the far right. And we've moved the pointer to free space to the second entry. So this is actually a design change from the previous picture. This is the design we want, in fact. So we're going to need this count, the number of slots, as the first entry in the page. Okay, that's fine. We can still find the pointer to free space. It's just one integer to the left, so to speak, from the end of the page. All right, and so we're going to track how many slots there are in the slot directory there, whether they're full or empty. Okay, so that number is just how many slots there are, period. Some might be empty, that's fine, but this is the number of slots. Now, if we want to extend the slot directory, it turns out we have more tuples that we want to put on this page and there's still free space. No problem. We can add another slot to the slot directory going right to left. We bump the count on this counter at the end, and everything's good, right? Basically, the slot directory goes from the end inwards to the middle, and the record storage grows from the beginning of the page inwards to the middle. And when the slot directory and the records kind of meet each other, that's when the page is full. So to summarize the slotted page, this is actually a very good general purpose data structure for storing records on a heap file page. It's good for variable or fixed length records. It's a little bit too expensive for fixed length records. We don't really need all these lengths, right? So it's a bit of a waste, but it is general purpose and it can work for both. So some systems might use only slotted pages. Some systems might special purpose fixed length page for fixed length records. That's certainly an option. Slotted pages are nice because they're easy to rearrange. If you have null fields, they simply become shorter records. That's fine. So even with fixed length records, if they're nullable fields, if the fields can accept the value null, they're actually not fixed length records. It's another reason why slotted pages are rather nice. If you have a whole table of fixed length non-null records, maybe you want to build the optimization of a fixed length format, which doesn't have to store lengths. But the slotted page format is general and quite useful, and so it's in most systems.